Hello, information technologists. Welcome to day 4 of CSC 505 Foundations of Information Technology. For those of you out here, I know you can't see my Dilbert cartoon because it's on the tiny plasma screens on either side of me. The boss says, "I've been so busy lately that I haven't had time to manage you. It must have been a nightmare for all of you to be without my leadership for so long." Alice says, "This might be a good time to lead us to the next topic on the agenda." Okay, thanks for playing along with me there. For those of you on campus, you had a quiz. Thank you very much. Here's your extra credit. Which CSC 505 student will not pass the class? I have appreciated you being engaged with me, not only cognizant, but for those of you on campus, making comments, answering questions, and things like that. It certainly makes, I think, it easier for you also. I would never require you to do discussion. I never require you to ask or answer questions. But you probably know if you are engaged that way, those are probably things that you will absolutely remember. By this point in your educational career, you also know that if you have a question, everybody else has that question also. Things that may seem obvious to the instructor are not always obvious to the student, are they? So thanks for being attentive and engaged there. This was not one of my classes, just in case you were wondering. We're doing the second half of Unit 2. This is the state of the art. We're going to be using the Brookshire text. Hey, look, I even brought my text. I can't move too far out of the line of sight of the camera because I want to make sure those of you at a distance. I'm having so much problem with the technology. Some of the course cast didn't catch, had to redo some things, etc. But anyway, we'll see if this works. We've been taking a look at a number of chapters in the Brookshire text. The first half we looked at 3 chapters, and this evening we'll look at 3 more chapters to really help solidify what might be current out there in information technology, both from an academic and from an industrial setting. You're not supposed to write this down. This is just my description of the unit. As you noticed in the homework set that you completed just prior to today, although there were some that were very IT-like, there are also others that may not have seemed very IT-like. But understanding some classical questions and their solutions is important also. And it's another way to see both the capabilities and limitations of computer systems. We're going to jump into the news, and in order to do that, I'm going to turn on the big screen, so I'm going to add another video source. Do I want to do that? I think I want to do this. What do you think? Yeah, I'll capture the screen too. That'll all be good. And now let's see if we can turn on the projector on campus, folks. We saw Yahoo News the first day, and then we saw maybe Google News, and then last time I think it might have been CNET. This is yet a 4th one, CNN. CNN, the letters stand for Cable News Network. They have a tremendous website. By tremendous, I mean large, not necessarily good. But they do have a number of things, and they do have a tech area on their website also. So let's see what they think is top of the news today, the 20th of February, 2014. Facebook's $19 billion move you might not notice. Yeah, Facebook is just I think we had this discussion before, right? How do companies make money online? And well, Facebook had an initial public offering. It wasn't quite. Facebook is a publicly traded company now. And the stock wasn't exactly what the founder and many other people had hoped for, but yet it's a little bit of money. So they do have a fairly large revenue base there. And for some reason, they keep generating funds also. Okay? So here it is. New apps helps you fight parking tickets. Bitcoin. Food stamps. Oh, okay, yeah, here's what I want to talk about. Bitcoin. Do you want to talk about Bitcoin? Anybody know what a Bitcoin is? Bitcoin. Yeah. And what company, Already blew it. What country mints Bitcoin? Answer is trick question. No country, right? This is just a private enterprise started off really for gaming types of transactions, but now has spilled over into the real world.
So expensive, one Bitcoin nowadays.
Is how much?
No, it's going up daily. Like,
Yeah.
It's changing. It's like dollars, you know.
Yeah, yeah, right. Yeah, it's several hundred or 584. What did I see? I don't know. Help us, Tosh.
$608. $608.
$608. Wow, one Bitcoin is $608. Okay. I guess if you haven't heard of Bitcoin, it would take a little bit. You might want to investigate it a little bit. This story is kind of interesting. One of the world's most prominent Bitcoin exchanges is in turmoil. A Bitcoin software glitch could allow thieves to steal its customers' Bitcoins. Ow. Yeah, right. Okay. So Bitcoin, which really started off as sort of an alternative currency among some tech folks. I don't have. Did anybody here have Bitcoins? Not me either. Okay. Yeah, right, exactly. Okay, so if you haven't heard of that before, it has a very interesting origin to it. Here's another one of those stories that if you don't know the origin of it, it's going to be really hard to understand. Yeah, Bitcoin. Here's one here. We've seen this couple of WhatsApp, 19 billion, yada yada. And a video game disc, Google Fiber maybe coming to this. So these are all interesting things.
Do you think they're going to change something with WhatsApp?
I don't know. I don't know. I would think so.
They're going to connect it with the Facebook.
Yes. Yeah. You would think so, wouldn't you? Yeah.
With as a separate application, not connected with the Facebook, like Instagram. Facebook now, the Facebook bought Instagram years ago and put it as a separate
Yes.
application.
Yep.
And they will with WhatsApp as what they did with the.
Yeah. Right.
The only thing
With
you
it.
have to look is like stop advertising. Don't put a pop-up. It'll sell them. If they do that, people will not application.
That's a very interesting business type of question, and that model is, that is very interesting. What is better, however you define that? An app that you have to license, that somebody has to pay a license fee for, or one that is going to bug you with the equivalent of pop-ups? Yeah. I think many of us probably have our own suspicion there. But the thing to realize is just because we like one way does not necessarily mean that might be the most profitable way for the company, right? Apparently targeted pop-up things work. Apparently they work. Right?
They get a lot of money.
They do get a lot of money.
Pay.
Yeah, exactly.
That's how BlackBerry goes on. Like I saw it like 6 months back.
I wonder how BlackBerry went on.
So BlackBerry Messenger, they told they've launched
Where's
it for
that?
all the other operating systems.
Uh-huh.
And people were talking about like how are they going to run BlackBerry?
Yeah.
So I thought like how are they going to run? Like everyone installs BBM.
Yeah.
They have access to the data,
Mm-hmm.
entire telephone data, your contacts and stuff.
Yeah.
So imagine how many governments are going to pay them. They
Yeah.
don't get money from advertisements of people.
Yeah.
Just installing it.
Right. Yeah.
Companies don't survive.
The little story here about BlackBerry, and some of you may know the origins and potential demise of that. Let me point out just one other one here. 3D printing ink is way too expensive. I want to talk about 3D printing with you. As a matter of fact, I have some articles here I'm going to pass around in just a minute. The department has a 3D printer. Yeah, we do use it. Yep. Mm-hmm. Can you use it? No. Okay. And it's not because the ink is too expensive. It's just because, well, I'll get to that. Okay. Here's the where's the story? Any story here? 3D printing ink is way too expensive. You notice they have ink in quotes here. Many consumer grade, what I think we would consider low-end 3D printers, use a type of plastic. There's a couple different kinds that are used, PLA and ABS and a couple other things, but they're basically plastic-like things. And this is saying, whoa, plastic filament, standard material used by 3D printers, typically range in price from 25 to 45 for a kilogram. Well, actually, it could be a lot more than that, depending upon how some manufacturers brand them. That's a huge markup over the $2 per kilogram cost of the pellets used to make the filaments. But even when add those costs, it's artificially inflated. Yep. Hershey has a chocolate printer and things like that. Question, comment.
That's the reason why they're like the people who designed that released it as an open source, because companies don't make money out of it.
And
3D printing.
help me with what being open source or not being open? 3D printers are open source?
They are a few open source.
Well, are you talking about
The design,
okay,
how you build it,
what you might, oh,
how it's made, it's open source.
okay. Well, it's not like it's a big secret, and I'm not sure the patent issues there are really interesting too. But you can get, I mean, there's a number of different ways of going about doing it, and I don't know if I would call it necessarily open source, but I think...
It's expensive to build it, but even I have to design it open source. I don't know.
Okay. Yeah, I mean, the design ideas is not that complex.
It's expensive.
Yeah. Okay, could be. Let's, okay, before I leave the news, I just want to again encourage you to find some source and keep up with that. You already had to do that for one assignment in this class, and there will be another one that asks you to do that. As I mentioned, the department does have a 3D printer. Maybe I should turn the, for those of you at a distance, maybe I should show you these things first, and then,
Sir, can we go and see it after the class?
maybe.
I saw it.
Okay, good. For those of you at a distance, I don't know if you can see this here. If I could zoom in, it's actually a pretty interesting thing. This is a internal gearing star, and I'm turning the center one, and you can see the ones around it are rotating around the ring. When I pass these around, you can just see the plastic involved here. These two here are a little more open design type of thing, and this one here is somewhat flexible. It's actually meant to be a bracelet. So I will pass these around, and what you'll notice is they are definitely made out of plastic. I'll explain how it works in just a second.
Take one home.
No, I'm sorry. And these are not mine either. They belong to my colleague, Professor Wall. And the reason that I'm not going to fire it up or let you do it yet is we're currently involved in we're setting up a demo for the university so they can see it. And I want to make sure that I don't mess up anything that he's up to there. Okay? But yeah, we could take a field trip.
The thing with the 3D printers that went crazy was when they built a weapon out of it.
Oh, okay.
Government started banning it.
Okay.
Raiding people.
Okay. Yeah.
Liberator, the best weapon.
The stories of weapons being created by 3D printers might be a little over-exaggerated. There are a couple different types and levels of 3D printers. Okay? The hobbyist ones, oh, I should have brought the filament for you, but anyway, they're basically long little strings of plastic. And what happens is the 3D printer will melt this plastic. It's about 230 degrees C or something like that, so it'll melt it. And then it starts laying down. The way that they work is, think about a 3D image of something, and basically if you just made a number of slices through it, sort of like a deck of cards, and you know how thin a card is, the 3D printer sort of builds up over time. So it'll lay down the bottommost layer, and then the next layer, and the next layer. And each one of these layers is very tiny. I don't know how many tenths of a millimeter it might be, but they're pretty tiny, and it just builds it up over time. And you might wonder, how long is this time? Well, I think the simplest object that I passed around there, I think the cross might have been somewhere in the neighborhood of 10 minutes. And the most complex one, that internal gearing one there, I know was more than an hour. Professor Wall is the expert here, and I just didn't double check all the facts and figures with him.
Do we have a class on?
We don't.
Oh.
Okay.
Does it come with sizes? I mean, does this printer can do chairs?
How big of a great point. You can't see it very well here, but I'll take it and show you to you. I think the biggest object that our printer could make is height limited, I don't know, maybe 5 or 6 inches. Length and width limited about 1 foot. Okay, so that gives you a rough idea. There are obviously bigger ones. There are others that don't deal with plastic, and there's a couple other technologies to do things out of metal and other materials too. The United States Navy has been, I think, kind of an industrial leader in this. Many ships in the United States Navy right now have a fairly sophisticated 3D printer on board, and if they need parts, they don't keep a lot of stockpile of individual parts. They just make them as they need them. So you need a new propeller, that might be pushing it, but if you needed a hatch or something else on a ship, they can actually create those at sea. Yes, made of an alloy. I can't tell you exactly what, I don't know, but yeah. And those printers, now again, some of this technology is classified, and I'm not an expert at all.
I found the design. I have a backup.
Okay. It's not like the same technology where they're melting metal and laying down the metal. They're actually milling it, and some with lasers and others with high-speed drills, etc. So they're starting with blocks of material and actually creating that way. Pardon me?
Multiple technologies used together.
Could be. Absolutely. Yeah. Okay. Good.
But I think the technique is more relevant with, for example, if the plastic maybe they're relevant with chemical, chemistry, and the other material design maybe made of engineering design. It's not the sole linked together with the information technology.
Okay. Good comment. The comment is, making these things, I can see that for certain industries like manufacturing or whatever, but how does this help us in IT? And what I'm going to say is, remember, in IT, we solve problems for other people. So I think this is a good illustration of that. Do I need to make something for me? It's hard to even think what that might be. Maybe an RJ45 end or something, It's hard to say what that. It would not be cost or time effective to do that either.
Trying to make it cost effective, 3D printing.
Yeah. It's a 3D printing at the low end. This is not plug and play. It's not like buying a DVR and setting it up. It's not quite push a button and away it comes. My colleague Professor Wall can tell you all his horror stories of trying to get the printer to actually work here. So, yeah.
So do we have a 3D scanner too?
We do not. Though that technology is much worse than 3D printers. This particular this is what we have. We have a so-called MakerBot. Okay. They also have a 3D scanner. The MakerBot 3D printer is a pain. Okay, is a pain. Let me just leave it at that. Their 3D scanner is really not ready for prime time. And again, if you want a 3D scanner that really is going to work, it's beyond many people's budget. Okay. Yeah, and MakerBot has a LaserTech 3D scanner. The suggested list price is $1,500. But the issue deals with the power of the laser and the lighting and the refractance, and it's just, it doesn't work really well. Yeah. Oh, yeah, we haven't even got to that. So good comment. We don't always create stuff for us, but this might be important for an industry, and we might be supporting them.
Like something breaks up and you need to repair that instantly, just print it out.
Yeah,
and put it in.
yeah. In that case, yeah, absolutely. Rather than having to wait 2 days for something, if you can, it would be cost effective. Yeah, absolutely. Good point. Question, comment, yeah.
Yeah, not a question. Just when you said about the technology news last time, I just made a web page about a person in Spanish made a robot with a 3D printer.
Okay,
I think
yeah.
that maybe I mean to say is maybe it's not directly with IT, but actually it is a way to fulfill our goals.
Mm-hmm.
Especially, for example, you said cable.
Mm-hmm.
Maybe I can buy a cable from supermarket, but it costs time, or maybe I need to drive out. But actually, if I can't have, if everyone has the accessibility with 3D printer, they can use their IT knowledge to make their own designs and whatever they want.
You bet.
That is actually a long lost dream, like, which is coming up now, 3D printing.
Mm-hmm.
They
Absolutely.
want to make it cost effective. Maybe
Sure.
a decade.
Yep.
But actually,
I'll say, like everything else.
I mean, the customer 3D printer is not really so expensive, but tens or thousands, hundreds.
Mm-hmm.
But actually, yes, that you said, the material is highly expensive.
Right. Yeah. And I probably didn't even tell you. This particular device is about $2,500, so $2,500 US dollars. The spool, which is a kilogram, 2.2 pounds worth of material, and I could show that to you too, is, well, that article said anywhere from 35 to 45. Actually, you know, if you want to ensure some quality stuff, you typically have to spend a little more than that. So, and I don't know. I mean, we've made all those things and many more with, as you can tell, that's nowhere near a kilogram worth of stuff. Right?
You're printing organs right now, kidney, heart, stomach.
Yeah, that's a completely,
Bioengineering.
different, thing. Completely different
Kidneys,
thing.
you know.
Yeah. Good
Next
comment.
7 years.
Yeah. Okay. Onward, then. Today, we're going to take a look at 3 other chapters in the first half of the Brookshire text, chapters 3, 4, and 6. And as last time, I'm not going to step you through step by step each of the chapters. And some of the things I'm going to be talking about are really not necessarily in the book, but maybe background information that will be helpful. And again, I will not necessarily be taking these chapters in order either. That won't fool you. I think you'll be able to deal with it. Now, I don't want to get your hopes up, but I will tell you, on-campus folks, when we're done tonight, we're halfway through this class. Or at least halfway through physically sitting in class. And as I told you before, the assignments are somewhat front-ended too. When you're done with the homework assignment set for today, and I know that will be a few more days from now, you will be well more than halfway through all the assignments in the class too. Okay? So we're going to try to lighten up a little bit. We'll see if that's possible. Okay. We're going to start with chapter 4. Again, don't panic because I'm not starting with 3, but we'll start with chapter 4, which is probably the easiest one to slide in on. Chapter 4, networking and the internet. Okay. If you're wondering why this is Roman numeral 3, I'm just going to keep the Roman numeral outline going throughout the unit. So last time we did a 0, 1, and 2. And again, you don't have to worry about the Roman numeral. It's just a way to let you know this is a new general topic. Let me give you a definition of data communications. Actually, interestingly, Brookshire kind of dances all around the subject and doesn't really give a good, or at least what I would consider a good definition of data communications. So, can we start there? Good. Computers transmitting binary form data. Data communication. Computers transmitting binary form data. A couple things I'll say. First of all, different people will have different definitions. But in our world, notice first of all that there needs to be multiple computers. You need 2 or more computers to do data communications. In other words, for our concern, what's happening between a keyboard and the processor is not data communications. Even though this is happening across a wireless channel, and even though the equivalent of binary form is flowing from this device, the keyboard, into the processor, this is not data communication. For our concern, it's computers, multiple computers, transmitting, send and receive. It's a two-way street. And binary form, as we saw last time, just the native tongue of a computer. So that's our operating definition of data communications. By the way, I mentioned this in the first unit. I just want you to remember, it sounds kind of trite to say that communication is important, but communication is important. Why? Problems are solved when information is communicated. In IT, like in other disciplines, problems are solved when information is communicated. In information technology, we really need to deal with communication on 3 different planes, 3 different points. One type of communication that we have to deal with is human-to-human communication. IT professionals have to interact with clients and customers and users. We have to understand their problem. We have to figure out requirements and specifications. We are interacting with other people a lot. That human-to-human communication is important in IT. I told you the first day, one of the things different about our program than some other ones is our heavy emphasis on people. I don't want IT professionals leaving here without being able to communicate to other human beings. And that's why you're writing, and that's why we're doing some other things here to ensure that you can do that communication as part of problem solving. Another plane, if you will, of communication is human to computer. And that's just the interface, like the user interface that we mentioned before. But there are other interfaces, and we'll see a couple today. That human to computer communication is also important. And a third type of communication that's important to us as an IT professional is computer to computer. And that's the subject of right now, datacom. Computer to computer communication, or datacom. Before we get into the text, well, sorry. I can say that after this one. In computer science and information technology, there are a few what I would consider fundamental concepts. And one of them is something called information theory. Now, for some of you who may have seen something like this before, the work of Claude Shannon, and sometimes people call what he did information theory. I'd rather call it Shannon theory or coding theory or something. Information theory says many different things to us in IT, but one fundamental thing that I want to emphasize in this class, and that's intelligence is recognized by the communication of information. Intelligence is recognized by the communication of information. What information theory is doing is it's connecting 2 of the grand ideas of IT together, information and intelligence. And it's connecting them into a cause and effect relationship. Intelligence is necessary to create information. Information theory says a lot of things, but this is one important thing to tuck away and remember. Comment. People supply intelligence. So human beings possess the intelligence of a system. In the 4th unit of this class, we'll talk about artificial intelligence and, is hardware and software together intelligent? Can hardware and software together be intelligent? That's a great question. And the answer is, as far as we're concerned, intelligence is a native attribute of human beings. Humans are naturally intelligent. We need to say some more about that, but I'm going to leave it. Good question. Okay? Question?
I have a question
Mm-hmm.
just about the fundament of the meaning of information. I just, for example, so I think Professor said at the beginning about the data information is the useful data.
Yes.
I think there are some, maybe there's a like a one part of intelligence is the human being's attribute. So if data, there are lots of data, but maybe they're useful. So only useful data is information. So I think it's a bit weird. That means only the data which human can recognize or can understand is the information. So I think maybe the intelligence and the information, they are on a whole, a complete meaning. They are combined together.
Yeah. I agree with everything you said, and I think the point is, this is tricky.
Yes.
Where's the dividing line between some of these things? And the answer is, it is necessarily blurred. Let's just step back to data versus information. The same number could potentially be both just data, or it could be useful information, right? Depending upon the context.
Yes, because based on the judgment of the human.
Yes, yep, I agree with you. Right. The other thing I should say, too, is people's, if you look, you'll see all different hierarchies of things. Data, information, and then a few other terms here on top of that, too. So, yeah, there's a lot of ways to slice it. Good point. Good point. For now, I don't want you to be so worried about, well, what? Here, I've got something. Is this X or is it Y? But just sort of see the pattern that's going to emerge. Yeah, that's a good point. Good point. I agree with you. To say, before we look at the technical stuff then, to say that there is power in communication is also a little bit trite. I think everybody would agree, yeah, communication is a very powerful thing. I want to share a story with you that I bet many of you have heard, and many people have heard it, but they fail to see, I think, one of the central meanings of the story. It's a pretty ancient story. There are several records of this. I'll just draw on the one that I'm most familiar with in the biblical text. It's the story of the Tower of Babel. This is recorded in the Old Testament book of Genesis. It's Genesis chapter 11. Pardon me?
Darwin wrote it?
Oh, no. Not, yeah. Genesis, yeah. Genesis is actually recorded. No. Darwin wrote The Origin of Species. Darwin rejected the book of Genesis. Okay. But, yeah, that's okay. Actually, God dictated Genesis to Moses, who wrote it down. It's okay. It's all right. If you knew what I do in my other life, you'd find that even more amusing, because I deal with cosmogony, which is the science of origins, which deals with evolution and creation. But another topic. Good comment. Yeah. The Tower of Babel, if you recognize the story, and there are many accounts of this, this is the origin of the major language groups on planet Earth. The narrative talks about God confusing the language, and different people had to move away from this, wherever the tower was, somewhere obviously in the Middle East, move away from that. But I think even when people know that story, they miss this interesting little tidbit. The whole world had one language and a common speech. So according to the biblical narrative, sometime approximately 4,000 years ago, everybody on the planet spoke the same language. Now, I don't know what that was. I know it wasn't English. That I'm positive of. I don't know exactly what it was, but everybody spoke the same language. That resulted in something interesting. Now, as Moses wrote down Genesis, this is a quote from God viewing this and saying the following. If as one people speaking the same language they have begun to do this, then nothing they plan to do will be impossible for them. Think about that statement. Nothing they plan to do will be impossible for them. Why? Common speech.
Communication.
Yes. Yeah. Okay, sure. Okay, let me give you a little background. You're wondering what's going on here. The historic context is this is a few hundred years after the flood of Noah's time. When human beings exited from the ark, God gave them command. He said, I want you to spread out over the surface of the earth as you were before. But the people decided they didn't want to do that. The people decided they're just going to stay congregated and build this great city. And then ultimately, after several generations or tens of generations, I don't know what it was, decided they would do this tower. The tower was basically a way to thumb their nose at God. God said, I want you to disperse. I want you to spread out over the surface of the earth. But they said, no, and this is going to be our unification. This shows that, we don't have to do what you tell us to do. So this is when, historically, then God came down. Let me skip ahead, and then I'll come back to this if we need to. Yeah, so this is after Noah's Ark, but still everybody spoke the same language. And God says, come, let us go down and confuse their language so they will not understand each other. If you talk to linguists today, they would tell you that there are about, I usually say 7 major language groups. Some people say 9, but there's a small number. And they all trace their origins to the near Middle East, 4,500, about 4,000 to 5,000 years ago. And this was the event that happened. Now, if you want to wrap your mind around the actual event, that's fine. I'll help you with that sometime. But the point is, do I have it here? No, I don't. The point is power in communication, right? I guess the postscript is, today, computers all speak the same language. Right? Binary form? Yeah. Great power? Maybe. I don't know. At least to keep our Bitcoin safe, we might have to.
Computer companies made different products equivalent.
Yeah, I know. But still today, fundamentally everything's in binary form. If you want to play with, if you want to transmit data from computer A to computer B, you got to use Unicode. If you make up your own encoding standard, nobody else knows what's happening. Yeah. Okay. Was there an A? I don't know. May not have been. I shouldn't. Okay, cool. Thank you. There was an A. If I miss something here, don't let that bother you. Hardware. There's some specialized hardware that's necessary for data communication. Fundamentally, you need at least 2 things to do data communications. You need a communications channel. Some people call that a link, a comm link. And I don't care. When you read through chapter 4, Brookshire's going to tell you about stuff. I don't care that you know all the different stuff, but conceptually you need to know that this is the medium used to transmit the binary or digital data. This is the medium used to transmit the binary or digital data. So a datacom is computer A talking to computer B. What's the medium used to do that? We just call that the channel. Could be physical, right? It could be wires. And of course, today it could also be wireless. We're not going to investigate the different technologies. That's for a different class. But if you're interested, there's lots of resources. Okay? So wire or wireless. And are you ready? Here we go. In honor of the windstorm that's approaching. And on Friday, we'll have a large area of wireless data blowing in from the west. It's funny, but if you ever stop and think about how much we're all bombarded with, right, EMF all the time. I mean, yeah, exactly. Just think of how much is bouncing off and going through our eyeballs right now. Makes you want to wear a mask, doesn't it? Okay. The other thing we need, so first of all, we need a medium to get from A to B. And the other thing you need is a communications interface device. A communications interface device. The language that the computer uses may not be the same language the channel uses. So, we need a device to translate that. So the interface device is used to translate the digital data of the computer into the form used on the channel. What are we talking about? Examples? What's an example of a communication interface device you'd find in a computer? Like, okay, modem. Okay, now the reason I'm not going to do keyboards is just because I want to keep that a separate thing from Datacom. Okay, but a modem, a NIC, a network interface card, you know, your wireless 802.11xqz729 stuff. Yep. So all these kinds of things. Some kind of communications interface device. Exactly.
Computers, right?
Correct. We're talking about between computers. So the purpose of this is to take the ones and zeros here, change it into whatever form is going to be used on the external connection, whether that's a wire or, this is wired too, or a wireless transmission.
Not the CPU.
No, not the CPU, right. Right.
Can I ask you what's the difference between the CPU and this device?
CPU, when it talks about the processor unit, is that entity that controls, directs everything else, and actually performs the processing. This device here, now, I don't want to say that. This device here can do some stuff, but its sole purpose is specified, unlike a CPU, which is a general purpose device. The goal of this thing is to take the ones and zeros from here, do something to it, and then send it out here. Does that help?
Yeah.
Okay.
As what? Send it out as what?
Depends upon what's on the channel. For example, if you've got copper wire, okay, then it's going to be sine wave, right? If you have a fiber optic cable, it's going to be a light pulse. Okay? So, you know, people talk about, I mean, all the time, the local phone company will say, we have DSL, digital subscriber line. It's not truly digital. This is not doing ones and zeros. It's not doing on, off, right? It's thrown, the information is thrown on top of a carrier wave that goes down here. Okay? So what I'm saying is computer 1010, you know, a 5 to a computer is reading from right to left 101. A 1 in the fours place, 1 in the ones place, a 6, 0, 1, 1, and so it goes. So when the computer thinks 6, 0, 1, 1, this device has to change that into whatever the channel uses to carry that same concept of 0, 1, 1. Yeah.
Like the ears, and that's like the brain.
Yeah, okay, good. The CPU is kind of like the brain,
Ears.
and this is kind of like ears on the one hand and mouth on the other, since it's two-way. Yeah, that's a good analogy. Okay, I like it. I'll steal it, use my own next time. Okay. Now, there's lots and lots of stuff. Don't answer this out loud. I just want you to think about it for a minute. Let me give you the context. I will oftentimes go to places, computer stores, and I'll just ask basic questions because I'm always interested to see what they'll tell me. You know? A fairly significant electronic chain in Wisconsin is Best Buy. And there's one a few miles up the road in Grafton. Every once in a while I'll go into Best Buy and you wander in there and the people want to help you. So yeah, ask the Geek Squad. And so every once in a while, and this is a question I posed, and I said, say, my internet connection is really slow. I got a friend that just blazes along here. What's the matter? And their answer was, you need a faster CPU. Okay? They said, well, how old's your computer? I said, I don't know. It's a couple years old. Well, what kind of processor is it? I don't know. A Pentium? Does that mean anything? Okay. Oh, your computer's too slow. Now, I want you to stop. Would a faster processor increase the speed of datacom? Let me tell you the answer. No. The answer is no. Now, why is that? Datacom happens between two computers. Let's go back to the brain and mouth analogy here, right? Let's say my mouth operates at this speed continuously. However, you would like me to talk faster so we can get done sooner with the class. Now, wouldn't you? You might think the way to do gotta stop that, is to give me a faster brain. But if my mouth is limited to this speed, does it matter how fast my brain is? No. Give you another, go.
Should be the other guy should understand what you're talking. If you talk a bit faster,
Mm-hmm.
he'll not understand. There's no meaning of that.
Okay,
So it has to go through the same.
Yeah.
And it has to be observed in the same.
Yeah,
time.
that could be true too. Yeah, absolutely. Give you another example. Let's say we have two cars, and you've got a road. One car is a 2013 ZR1 Corvette, top speed 206 miles per hour. The other car is a 1977 Yugo, top speed 37 miles an hour. Now, you say, well, the one is obviously going to get there faster than the other. Here's the catch. You're driving down Port Washington. It's not called Port Washington. No. What is it? Highland Road, south of campus. Speed limit, 25 miles an hour. Does it matter whether the top speed is 206 or 37? No. Now you're saying, well, I'm going to speed. No, because there's a police officer with a radar gun every 2 blocks, right? See, it doesn't matter. In this case, the car is like the CPU. The channel is like the road.
There are limitations.
Exactly. What I need is not a faster CPU. I need a faster channel. And this is actually really true. I live out in the country. I don't have a T1 line pulled up. I don't have fiber optic cable going to my house. Okay? I depend upon a really weird setup. Okay? Comment.
If we have like a very fast channel,
Mm-hmm.
and the CPU is too slow.
Mm-hmm. That's okay. You just won't be using up the capacity of the channel. You're just.
So it's kind of related, right?
It is kind of related, sure. But interestingly, in most circumstances, it would be really hard to have a semi-competent CPU, you know, tax a channel. Yeah.
Told us about the system IT model.
Yeah.
It may have a 3D thing, but the software, same
Yep.
like that.
Mm-hmm.
You may have that if you don't have this. You
Yeah.
don't have this Dakota.
Right. I don't know if this helps, but you know, in the early days of personal computing, the speed of the CPU is measured in megahertz, not gigahertz. But nobody could type so fast that they could tax. I mean, nobody got to the point where they could type so fast the CPU said, "Whoa, slow down!" Right? Yeah, trying to. It's true, it's related, but typically our problem is the channel being the bottleneck, not that it's so wide open that we can't fill it. Yeah, good question.
The newer generation chips have built-in Wi-Fi chips, so
Mhm.
the faster the core, the faster the Wi-Fi. It's not out. It's maybe out of 4 or 5 years. Built-in Wi-Fi chip.
It's yes, but it still depends upon the speed of the channel, and that's set by the standards, right? Whether it's 802.11g and AX29, whatever they are today.
802.11, there's another standard for Wi-Fi. It's not out.
Are you talking about? You're talking about the AN? I don't remember.
Wi-Fi standard, I think there's another one.
Yes, yeah.
It's not out.
Well, yes. Keep
So
going.
If I gonna buy a new device and I wanna know about the channel speed, should I
Mhm.
know about the speed?
Yeah. No. The channel speed is completely independent of the speed of your CPU. Channel speed completely independent. For example, if you are a individual consumer, if you're a homeowner, if you live in a concentrated area, an urban neighborhood, then there could be a couple different options available to you, like your local cable company, your local phone company. They can actually be pulling wires to individual houses. Depending upon the technology being used, they can offer you various speeds of service. Yeah, and you pay more for the faster, of course. That is completely independent of the speed of your CPU.
Which is used by gigahertz, right?
Yeah, today most personal computer CPUs, we measure their speed in gigahertz. Yeah.
For even the smartphones.
Yeah, there are some phones that may be approaching billion instruction cycles per second. Yeah. Okay. Good question. Yeah, I don't know if that helps anything. So, what's the answer to that question? Speed of datacom depends not upon the speed of the processor, but upon speed of the channel primarily, a little bit with the interface device, but really it's the speed of the channel. If you are, well, okay, we did that enough. Okay. Software for datacom, I'm not going to, we know we use data communication software all the time, whether that's an email client or whether that's your browser or whatever it might be. We use that software all the time. So I just want to remind you again that in IT, hardware and software are going to work together. Hardware provides the capabilities, what's possible. Software provides the abilities, what's probable or likely. So again, let's say I have a really fast CPU. I could really pump out some high-def video, really quickly here. But if my hardware limits that, because my channel is 3 megabits per second, then, well, it doesn't matter how fast doesn't matter how fast the CPU is processing based upon the software. I'm really limited by that channel from A to B.
Back to the channel.
Mm-hmm.
If I like put my computer and it will take like 6 seconds to be started.
Mm-hmm.
Is that about the CPU or about the channel?
Specifically on PowerUp, it's as much about your peripheral devices, because on the Power On self-test, what your computer is doing is it needs to check out everything. We're talking about powering it up, right? Mm-hmm. Yeah. Why does it take a certain amount of time? Mainly because you are checking out all the hardware, and secondly, you need to load the operating system. So your speed limitation is loading the operating system is how quickly your storage can pump it into memory. And the others is just the speed of the peripherals responding to the CPU's request. How are you? Yeah, good question. Question, Carl?
The thing about cloud computing, because the internet speeds have gone faster, you don't have to run anything on the computer. Just everything runs it there, the servers run it.
Yes, and in the future, we're going to talk about computing everywhere in the cloud, which works really well when you're sitting at a place with really nice high bandwidth Wi-Fi and a real fast back-end pipe. If you're in the middle of North Dakota on a drilling rig, it don't work as well, right? Don't forget about that. I mean, ultimately, yeah, sure, we're sitting here, we've got some, well, I don't know about our wireless, but we have some fairly nice connectivity here, but not everybody does.
Bring down the prices of you there.
Maybe. Yeah, maybe, but it's, anyway, we're going to
Doing
get...
that actually, like Google was doing it, like $299 Chromebook.
Well, yeah, right, sure, exactly. But again, a Chromebook's going to do you no good if you have, if you're in the middle. I see, I guess I'm more in tune to that because I live out in the country.
You need network.
Yeah, yeah. You need that infrastructure. And we're going to talk about that. Good. So let's not talk about that. Two fundamental major applications of Datacom. Both you know about. I just want to say a couple things about it because you need to read about it in Chapter 4. The two major applications of Datacom are, first of all, a LAN. The letters stand for Local Area Network. And I don't care that you know anything about the variants here. There are WANs and MANs and VLANs and other kinds. I don't care. When you see anything 3 or 4 letter acronym that ends with AN, well, I want you to think about network. I want you to remember this. The fundamental purpose of a network is to share resources. The purpose of a network is to share resources. Example. Share resources, yeah. A resource, for example, could be a printer, could be a physical thing, could also be a logical entity like a file.
Anything, video, file.
Yeah, exactly. If you go next door into S114D and look around, you'll see that there's not one printer by every computer. Don't need it. There are two. There's a large color one, there's a large monochrome one. They're all shared. Anybody can print to any of them. Why? Because the network shares resources. Yes, absolutely. And sharing is nice and polite. In data communication, you know, before I told you computer A and computer B, and that's not what we call the two computers. The two computers involved in Datacom, the client, by definition, a client computer requests a resource. It asks for something. So, if you're in the lab next door and you're doing word processing and you're ready to print, when you issue the print command within Microsoft Office Word, your client now has requested that resource known as the printer. The other computer involved in Datacom is the server. And by definition, the server provides those resources.
Connects them all together to a center.
Exactly. When you ask to print, we have a device. There's a combination of hardware and software. The software is called PaperCut. The device itself is called a print server. And those two things working together will say, okay, we will satisfy your request to print. Send me your job. I will then send it on. Of course, the reason that you have to do it to the server is because if you have two people who want to print at the same time, we need to synchronize that. We'll need to check to make sure you've got enough print credits. We need to make sure there's nothing wrong with the printer.
Which request goes to it?
Exactly. Okay, so client requests something, server provides that.
For example, if two clients request information at the same time,
Mm-hmm.
is the server going to provide it at the same time or as a queue?
Well, it depends on what the resource is, but very likely sequentially. Okay. If the resource was a logical entity like a file, I mean, we could conceivably send that file to both at the same time. If it's a physical entity like a printer, I can't let them both print at the same time, right? Okay. Yeah, this is an operating system issue. Mm-hmm. Yeah, good point. Okay. As you're going through Chapter 4, as you're reading that, I want you to pay attention to client-server processing. In addition to sharing, there's also another way to think about a use of Datacom in a network, and that's client-server processing. Here we can, I was going to say, share a processing load. I don't want to confuse you on that, but let's leave it at this. As you're going through that, be sure you focus on this idea of client-server processing and what happens.
Maybe it can share operating system.
That is possible.
Because we use it.
Yes.
We sometimes just flash the screen.
Yeah.
Have main.
Right. That's possible in a couple different ways. Yes. To share an operating system.
So we just did all the time.
Yeah, we're going to have to talk about reentrancy. Yeah, we're not going to do it. So we'll just say yeah. Yeah, that's possible. We can share logical things like files and software. We could share physical things like printers and projectors and what have you. Okay, good. I know we're almost due, but I want to, you know what? We don't really have to do this. I think we really know what this is. I do want to talk about this, though. Anybody use the term World Wide Web? I don't think anybody says that anymore. That's what the WWW stands for, the World Wide Web, just for trivia there. But on the web, there are two fundamental interfaces, and I'll just mention them, and again, as you're reading through Chapter 4, I want you to pay attention to this. One interface is HTML. Now, if you know what the letters stand for, that's good. I'd never ask, though. Instead, I want you to think this way. Yeah, okay. Hypertext markup language. Who cares? Yeah. Think of it this way. HTML is the language of a web page. And we're going to investigate it a little bit today. HTML is the language of a web page. As an interface, this is the user-to-computer interface. Just tuck that away. We'll see it in just a second. The other major interface on the web is something called HTTP, and there are variants of this. Yes.
Secure and unsecure.
Yes. Yes. And hypertext transfer protocol. Yes, yes, yes. I'd rather that you remember this is the language of web data communication. In other words, this is the computer-to-computer interface. HTML, user-to-computer. HTTP, computer-to-computer.
They work both, right?
Yes, both are used in any web session.
Like a client to server.
Yes, absolutely. Like a client server, absolutely. The P here, protocol. A protocol is just an agreed convention. In other words, you know, if you all started talking at the same time, well, we'd be done sooner. Okay, but nobody'd understand anything, right? So the agreed protocol is either, you know, you raise your hand or you wait till I make eye contact with you or something like that, right? Yeah, that's just a protocol. Same thing on the web. The protocol is just, here's how the client and server agreed to talk to each other. All right. In Chapter 4, I'm going to ask you to take a look at HTML. And the last thing today, we're going to take a look at a way to investigate that even more fully. HTML, the idea of a markup language is this is describing how things look. HTML is not the data, but it is the appearance. HTML is formatting. So you're going to read through, this is just figure 4.9, a simple web page. This is the HTML. In the bad old days, if you were a web designer, you'd have to write stuff like this. But this is actually what a web server might send to your client. Now, this is not what you see. What you see is via the interface of the browser that changes this into that. Right? Exactly. So this is the source code, and then this is what it ends up looking like. Some of us have worked with HTML before. Some of us sort of know what it is. But I'm going to ask you to investigate a little bit. First in the context here, and then I'm going to show you another tool for doing that. Okay? Technology usually doesn't scare me, but there's something about a World Wide Web that creeps me out. Yeah, not to mention the net. Thanks. Okay, you know what? I can come back and do that. Yeah. Okay. All right. I don't want to leave it purely technical. Interesting phenomenon about the web today. Man, there's a lot of stuff out there, right? There's a lot of stuff out there. The writer of the Old Testament book of Proverbs, likely King Solomon, wrote, "A wise man fears the Lord and shuns evil." And man, is it hard to shun evil in the online world. There's a whole bunch of stuff out there, right? Yeah. Now, yeah, why, as IT professionals, why would we care about morally questionable websites? Why would we care about a site that promotes gambling, or a site that promotes anarchy against the government, or a site that promotes how to make explosive, or a site that promotes pornography, or whatever it might be? Here's why. Because if your users somehow get involved with this, the company may be liable. You individually may be liable as the IT professional. I'll give you an example. Many companies, including Concordia University of Wisconsin, require all their employees to take sexual harassment awareness training. So what constitutes sexual harassment in the workplace? And some of this deals with, the display of inappropriate images on your computer. If someone in the workplace felt threatened by what somebody else is doing on their computer, that absolutely reflects on us. This is why many places, including Concordia University of Wisconsin, filter web content, right? If you want to get to any possible site anywhere in the world, you can't necessarily do that from here. Has this ever happened to you? I should have had a site ready for this. Did you ever, and this happens a lot, so you search someplace and you get one of these weird messages that pops up around here? What do you suppose a gambling site is? Do you suppose gambling.com, you think that's a real site? I guess so. If on this campus you've seen this, this page cannot be displayed. Based on your organization's access policies, access to this website, www.gambling.com, is blocked because the web category gambling is not allowed. You cannot access a gambling website through our servers. Now, as a user here, you might say, well, that's not fair.
You even showed me for Angel.
Did it? You're doing something on Angel and it wouldn't let you go there? That's funny. Oh, okay, all right. Okay, sometimes this might just be transient. Okay, just read what this says here, yeah. But I guess what I'm pointing out is we could potentially be held liable for the actions of our users. Yeah, we know this. That's funny. This is funny. You like this cartoon? See, it's a dog looking at a trash can, and the other dog says, "Are you looking at filth on the internet again?" We're trying to not only protect our users, but again, you can imagine that this stuff costs money, and from a business sense, we don't want our employees gambling half the day, right? Yeah, exactly. So it's part of what almost every organization calls AUP, Acceptable Use Policy. And you can find ours online, too. Okay, maybe the last thing I want to share with you, and then finally we can take a break. We've been talking about data communication. We've been talking about other kinds of communication, like human to human and user to computer, etc. And there's one really odd phenomenon today. 2014. The capability of communication is greater now than at any previous time in history. The amount of stuff, I neither want to use the term data or information available out there, is huge. Nobody knows. How many quad, giga, tetrabytes are there? Who knows, right? We have an abundance of communication, but yet we also have an inflation of communication. Great question. Let me explain what I mean by inflation. In a country, when their monetary unit goes through inflation, it means that although you have more money, it's worth less. Inflation means you have more of it, but intrinsically it's worth less. The value, inflate, blow up. So I got more of it, but when that happens, it's actually individually worth less. Okay? That's interesting, isn't it?
It's not going to everyone. Only
True.
few people accessing it. There is info, but
Okay.
people don't know about it.
Uh-huh.
It's not being advertised.
Okay. But the other thing to say about that is many people do have access. I
Too
mean,
much.
how many people? Yeah.
They don't understand what to exactly.
Sure, sure. So what I'm saying, let me give you one specific example. Let's say you didn't understand a tech term. So you went to your favorite search engine like Google, typed in that tech term. How many different sites could you possibly receive? Hundreds of thousands, right? If you compare site 1, 3, 7, and 10, you discover that they all say something slightly different. Which one is true? Huh. That's the point.
That's just too much information.
Yeah, there's too much, and yeah, a lot of this stuff we wouldn't even consider information, would we? It's just stuff, just junk. Yeah. Okay. Section 4.5 deals with security. Now, if you are also in CSE 501, you already took a look at this, but I'm going to ask you a different question in this class about that same section on security. It applies a whole lot to the online world. Company policy says I have to rate 1/3 of my staff as does not meet expectations. I chose the two of you because you have no upper body strength. This way it's safer if you go berserk. I thought you said I should tell them the reason I picked them, not the real reason. Okay, finally. Let's take a break, shall we?